Thank you, Dominic. Thank you, everybody, for inviting me here today. You know, I made my postdoc here in the civil engineering department, so I kept very good memories, and each time that I'm coming back, that's always good for me. So thank you for that. Okay, now I will present you some. Yes, I will talk about resource recovery, of course, but I will try to talk about some aspect of resource recovery that maybe my colleague will not talk about, and I hope it will feed our discussion later. So, okay. Yes, resource recovery, that's good for actually to achieve circular economy. That's very popular now. We want to maximize the circular economy in our cities and our industrial park, etc. But something important, that's not only technical or theoretical resource recovery, okay? It is important because it shall be based on social, economical, and environmental sustainability aspect. I will talk a little bit about that, and after I will show you some case study, and I will try to insist on this aspect. Okay, so in my case, I'm focusing mostly on biomass. I'm specializing in resource recovery based on biomass. So for me, biomass is a tool of regional development. I'm trying to get the maximum products on a site, in a region, and try to get synergy between local business. That's my specialty. And now I will just try to speak a little bit about all the socioeconomical, environmental sustainability aspect related to the biomass. Before the facts, you know, outside the large city, outside of McGill University, there's region, and there's some problem there. There's some local realities, like, for example, factories shutting down, which means that if we want to think about resource recovery, we may think about giving importance to this factory who can be closed, try to use their equipment for other purposes. I'm always giving the example of pulp and paper plant. Yes, there's technology to make paper, but we can make something else with this technology, so we have to think about that. And about the regional assets, you know, if you want to make a resource recovery project successful, you have to involve, by example, the local expertise, the local equipment that are in the region. If, by example, you want to work with forest residue, you have to involve in your project the people who are expert in harvesting this forest residue, sawmill, the people like this, though. So we have to think about that. And, of course, all this biomass and new or more biomass co-produced can boost local economics, and that is very important. But we need to consider a lot of socioeconomic sustainability aspects, and I will enumerate some. By example, we need always to think about how we can improve the social situation of the people in the region. We have to think about how we can catalyze partnership, business growth, economic activity, how we can give a new life to some infrastructure that we can find in the region, how we can stop the exodus of young people. It is a big problem. The brains are going out from the region. Everybody wants to keep them there to help them to develop the region. Try to create jobs, yes, but also now we are more speaking about try to retain job, to maintain job. That's now becoming more and more important in region. And also try to see if we can start business from, by example, biomass products or co-products. And also try to think about how, with these projects that we can make for biomass, for example, we can attract new business or retain some business in the region. Well, there's also the environmental sustainability aspect. You know most of them, but I will just pass rapidly through it. But I think the idea is to follow the principle maybe of industrial ecology as trying to achieve as much possible the circular economy, and it helps to gain environmental to get environmental sustainability aspect. So all these aspects can help to get social accessibility, mobilize a champion, because that's an important part of all the projects related to resource recovery. You have to involve the people that are willing to make resource recovery. retain stakeholder, maximize the overall social reach. So what I will do, I will show you some project, and I will try to explain you some aspect that I will highlight some of the aspect in my project that I will present you. So I will present you four case study, one related to the agricultural sector, the other one to the forest sector, one related to the chemical sector, and the fourth one related to microbiology. You will see what we can do with microbiology this time. It is very interesting in terms of industrial symbiosis. Okay, the first case. That's, we call it the AgroSerre project. It is a project in the région Trois-Rivières in Quebec, Canada. It is a region where there is a lot of farming activity, a lot of agricultural activity, but they have some socioeconomic problem. It's difficult for the farmers to encourage their children to take care of the perennity of their land, you know. So they don't know really what to do, but in such a region, there's a lot of lignocellulosic residue available, so they can make something from that. They can try to get new income from that. So there's two young brothers, the brother Lépine, who start a business called AgroSerre with one local business, the Prof, which is a cooperative of farmers in that place. And they start a project called AgroSerre. It was about integrating an ethanol cellulosic pilot plant to their farm. Okay, and we really have, in that project, what was very interesting is that we have covered all the entire chain of value of the cellulosic ethanol production, from the corn crop harvesting to the cellulosic ethanol. It was very interesting for that. So we work on practically all the aspects. We work on a way to make sustainable and clean harvesting of corn crop residue and the smaller area possible. We work on each step, including of course the step of the pre-treatment, allowing us to get from the corn crop residue the cellulose, the hemicellulose, the lignin, so the three main products. Of course, the cellulose is going to be converted into glucose with enzyme and after making ethanol. That's an easy part. But the most important part was what we were doing with the co-products, okay? Because it is difficult to make cellulosic ethanol production profitable, but when you think locally, when you think about giving value to the co-products, you can make it profitable. In this case, the cellulose were sent to the pig feeding because our farmer partner was a pig producer. They were feeding about 20,000 pigs per year, so they need a lot of animal feed. But by sending the hemicellulose to the pig feeding, we were making a lot of savings on the animal feeding, and we're able to make profitable the cellulosic ethanol line. Also, the lignin, of course, we can burn it and get some heat from it, but with a strategic partnership, a local business, like Prof, we were able to use it as a binding agent for animal feed. So it gave value to the co-products, and it helped to make all of this profitable. Bon, speaking about resource recovery, you know there's a lot of residue generated at the farm, around the farm, by other local business. Also by the cellulosic ethanol production, there's some organic residue. So the idea was to produce locally the enzyme used to convert the cellulose into the glucose. And we work a lot on that part with DuPont Industrial Bioscience, and also one pulp and paper plant that was about 30 kilometers of the farm. And we have developed a process to produce the enzyme using the pulp and paper sludge. And the company, DuPont Industrial Bioscience, was ready to implant a kind of micro plant to produce enzyme for all of this process there. And the idea, because we had some facility to produce enzyme, to produce industrial microorganisms, we were thinking about producing other industrial microorganisms as some biocontrol agent for specific application, by example, to use as biopesticide to replace some chemical pesticide used by our farmer. So that was one of our first example of some kind of circular economy based on resource recovery that we made. It became, with time, a concept of producing cellulosic sugar instead of cellulosic ethanol for many reasons, more political reasons. And this concept was finally a kind of advanced regional biomass processing depot. Such a concept is existing other places in the world, like United States. But in our case, we had a kind of concept with that was distinguished itself with some kind of co-products module and another enzyme on-site enzyme production module. And we got later the interest of the company DuPont and another division of DuPont because our lignin was a special lignin. It has very interesting properties to make phenolic resin, and we got the interest of DuPont on that. But I will insist on the socioeconomic impact of this project. You know, it was a project that was driven by a new generation of young farmers. For us, it was very important, and I think that it is very important when we are speaking about resource recovery, we have to involve our young people. And also, the idea was to attract new business like DuPont Industrial Bioscience and the region to create more jobs. Okay, so that was our case study about the agricultural residue. Now, about the forest residue, we have one. Maybe you heard about it. It is a LATUC project. It is actually the flagship project of the federal government and the provincial government on the forest residue biorefinery. It is based at LATUC. LATUC is in the region of Mauricie. It is at the Haut-Saint-Maurice region. It is a region where there's a lot of forest industry activity. There's their problem also because some sawmill are closing down, so they are losing job there. And the thing about how they can diversify the products for the forest industry. And one interesting thing is they are generating a lot of forest residue each year. We have a lot of numbers related to that, but there's a lot of forest residue there where we can use to give value and try to reboost the local economics. But and then that type of project is always challenge. This one, the forest residue are spread over a very big territory, 10,000 kilometers square. So we have to think about some technology, some technique to try to reduce the cost of biomass supply. We have to think about biomass densification. So instead of bringing from forest residue branch, by example, from one point to another, we are bringing oil. So we are making pyrolysis, some kind of mobile pyrolysis system. So the idea was, yes, we have the forest residue. The idea was to think about making some kind of mobile pyrolysis to get the oil and bring oil to a bio-oil to a central biorefinery in LATUC and get renewable fuel for EV forest vehicle fleet of the place, or to try to achieve some kind of autonomy in terms of energy at the LATUC city. The idea also was to attract new business. The Air Liquide is very interesting to set a plan there to transform the bio-oil into hydrogen and distribute hydrogen around Quebec. But there's also a Finland petrochemical industry that is very interesting to come here, and we have made a lot of deal with them. And if our technico-economical study is positive, they shall invest in a biorefinery at LATUC. So now I will talk about another case study that we are working on in Quebec. It is related to the Bécancour and Waterfront Industrial Park. It is between Quebec and Montreal. It is near Trois-Rivières. And there, what is interesting is this is a park where the chemical industry are there. And you know, in the world of biorefining, we always try to connect to the chemical industry. So there's a good, very interesting place there to connect biomass to the biorefinery, because there's a lot of chemical industry. This park is surrounded by tons of agri-forest biomass and also recycled wood waste. And also it is for those who know about what has happened in Sarnia in Ontario, it is a similar situation to Sarnia in Ontario. Speaking of Sarnia, in Ontario, you know, in 2003, some of the business and the industrial park, like the non-chemicals, depart. They have stopped their activity there. So it was it was not good from a point of view of job and all of this. So they got some problems, socioeconomical problem there, and they were looking for a way to reboost their local economics. And after 10 years, they have succeeded to attract bioénergie, okay, a succinic acid production company who is producing succinic acid from sugar, and they have made a lot of study like using corn stover to make the sugar and feed the plant of bioénergie. And by doing this, they have succeeded to attract bioénergie in 2013. So now there's a plant there and a lot of job that has created. So the idea for us was to be inspired by this model and try to do that in the Bécancour Waterfront Industrial Park. Our idea was to bring the concept of agrosphère that I just showed you personally, and make, of course, some kind of biomass, cellulose, hemicellulose, or whatever, cellulosic sugar, and feed an biorefinery that we can attract air in the park, and then try to make products for local plant. By example, we can use the cellulosic sugar to produce glycerol for Arkema by using, by example, the hydrogen byproducts of Olin, a chlor company manufacturer. So there was some kind of idea that was raising there by bringing organic matter, by bringing biomass into the biopark. We are thinking also about other users in the same region. By example, using the lignin to make some kind of biobitumus for Suprema, and also try maybe to attract some other industry like bioénergie. And the idea was to use the byproducts of the park, like hydrogens and other potential chemical catalysis, to make some kind of chemical conversion of cellulose and hemicellulose into valuable products. That it. So, and the idea and that project, it is when we bring organic matter, when we bring a lot of biomass into an industrial park, you are creating a lot more synergy between enterprise, between the local business. That was the idea at the end, to try to create more industrial symbiosis as possible by bringing biomass into the park. Bon, now we'll speak rapidly about microalgae biomass production. We have many case studies about that. We didn't expect that it may become popular in our research program, because we always known that it is very difficult to make it profitable, but it is very, very interesting in terms of synergy. The algae-based products are used since many years, but in the last 10 years, they have a new growing interest, since they are saw as a third-generation biofuel and a sustainable way to capture carbon. It's why we can hear more about microbiology production in the last year. In our case, that's strange because we have started a project with the aluminum sector with Rio Tinto Alcan for many reasons. Rio Tinto Alcan was thinking about being green and try to use renewable fuel from forest residue, for example, because they were especially in a forest region. But it was difficult for them to secure over mid-term or long-term the supply of the residual, the forest residue. So they were telling, well, what we can do, maybe we can produce our own biomass, but they will not produce tree or corn or whatever. But they have wastewater, and wastewater microalgae are used to grow in that. So we start this way a microalgae project. So the idea was to attract a microalgae producer around the smelter plant, one of the smelter plant of Rio Tinto Alcan, use their wastewater as source of nutrient for the microalgae, and use also the waste energy to heat the tank, to keep at constant temperature the tank over all of the year, even winters. And also, as microalgae production needs a lot of nutrient, they were thinking about using other local cheap source of nutrient from the dairy industries, by example. And the idea was to use also some local equipment to process the algae biomass. We have adapted a lot of pulp and paper technology to harvest and dewaterate the algae biomass to give us a very high-rich oil, lipid algae biomass. From it, there were a lot of things that we were able to do, but that we have tried to do. But the best route of valorization was to transform it into a biocrude that we were able to use it at the smelter plant, so and the smelter plant directly, or in the heavy vehicle fleet of the Rio Tinto Alcan. Based on this project, there were many other projects that came from it. One other interesting was the one at Cité of Victoriaville and the industrial park of Victoriaville. The idea was to produce algae in collocation with the dairy industry, Parmalat, who is making cheese, the Ficello, if you know what it is, and use other type of wastewater and the same industrial park to make a kind of recipe and grow a specific strain of algae that will allow us to get C12 and C14 fatty acids. These fatty acids can be converted to some interesting molecule that make surfactant for one local business, Sanimac, which is at about less than 1 kilometer of the Parmalat. So we were able to create some kind of unusual synergy between a chemical industry like Sanimac and a dairy industry like Parmalat. And the idea also was to convert the residual, the post-extracted residual algae into biocrude for the fleet of e-vehicle of Cité of Victoriaville and other company involved in the project. Also, we got the same similar project with ABI, waste management, municipal solid waste management company who owns a landfill site in Berthierville near Montreal. And the idea was to use the waste nutrient available on site, the leachate, some organic residue, even the treated water, to grow algae. And in their case, this company is very good to use the biogas as fuel for the vehicle fleet, which means that they have a technology that concentrates methane and finally separate methane from CO2. So we had a very interesting CO2 stream there that we can use also to grow our algae. And the idea was mostly to convert the algae biomass into biocrude and try to make products from it that can be used by UBE and also by other local business. So to conclude, here are some tips from successful resource recovery project that I want to share with you. As you can see, we are mostly thinking local before going globally. So I think it is important try to establish the most possible, as much possible, local cooperation, use local expertise and facilities, co-locate. Co-locate is very interesting way of thinking and working. Always try to cover the entire value chain. Yes, you know, our university researchers like us, we are used to work alone, but there's other group like college. Here in Quebec, we have the Technological Transfer College Center, the CCTT, who you can find very interesting people that can join your team and cover the entire value chain with you. Also, it's always very important, I think, to involve other type of group, other type of people, like the city people. For me, and all of my project, as you can see, it is always in a region, so I am always involving the city administrators, stakeholders, citizens, and all of the project. Why? Because it helped me to achieve all the sustainable socioeconomic aspect. And it helped me to contribute to maximize and achieve circular economy, to facilitate development of partnership with the local business as well as logistic of the project, and also give some kind of meaning to our scientific and professional work because it allows us to be closer to the final user, the citizens. Okay, but the best tip, I think it is involving the young people and all of your project. If you have partner, try to involve the young people at your partners, because I'm always giving the example that when you involve the next generation of farmer and forester, and you show them the possibility of new income and their role and dedication to secure biomass supply at appropriate quality and abundancy for our project, it is always good, I can tell you. So that it's what I had to tell you today, this evening. Thank you.